11 thermal properties of matter, question number 11.19. It says a cubical ice box of side length 30 centimeter has a thickness of 5 centimeter and it contains 4 kg of ice, and we have to estimate the amount of ice remaining after 6 hours. Outside temperature is 45 degrees Celsius. Coefficient thermal conductivity of thermocol is given, and this is the heat of fusion of water. Now you see, I can say that the amount of heat conducted by conduction in 6 hours should be equal to amount of heat absorbed by ice. Now the amount of heat conducted in 6 hours, then the rate of heat flow is, we know, Ka delta T by L into time. This is the rate of heat flow. If I multiply with time, this gives me the total heat conducted in time T. And that should be, now let us suppose that the mass of ice melting is m into latent heat of fusion of ice. That gives me the mass of ice which has melted is equal to Ka delta T into T divided by length into latent heat of fusion. Now mass is equal to, now K is 0.01. Area is, now you see, if it is a cubical box, there are 6 phases of side length L each, and thereby each phase will have area L square. And since there are 6 phases, I can write it is 6 into L square. L is 30 centimeter, that's why 0.3 square. Into temperature difference is 45 degrees Celsius. Time is 6 hours, so 6 into 36, 100. So this I have converted time into seconds. Divide by length, so it is of thickness 5 centimeter, that's why 0.05 meters, into this latent heat of fusion of ice, that is 335 into 10 is to power 3. This gives the mass to be 0.313 kilograms. This is the mass of ice which has melted, and thereby I can say that the mass of ice left is equal to 4 kilograms minus 0.313, that is 3.687 kilograms.